Hello everyone. In this video, we will learn how to derive the expression for the electric field at any point on the axial line of an electric dipole. So let's start. First of all, consider an electric dipole consisting of charge plus q and minus q. So this is our electric dipole consisting of negative charge and positive charge separated by a distance 2a. So separating by a distance of 2a, and it is placed in vacuum. Now let P be the point on the axial line at a distance r from the center of the electric dipole on the side of positive charge, right? So we have to find the electric field due to this dipole at the point P. Now the electric field due to charge minus q at point P is, we know from the Coulomb's law, the electric field expression is 1 by 4 pi epsilon naught into charge by the distance square. So in this case, for the negative charge minus q, it will be E minus q, and the charge is minus q divided by 4 pi epsilon naught and the distance square. Here it is r plus a whole square, because the distance from minus q to p is this minus q to plus q is 2a, so this will be a, this part will be a, so the total will be a plus r whole square, that is the r plus a whole square, and the direction is from towards left. Because of the negative charge, the electric field direction will be towards left, that is E of minus q here given it. So here the p hat is a unit vector along the dipole axis from minus q to plus q, minus q to plus q. This is the dipole vector, we can say. Now next, now the electric field due to charge plus q at point P is, so the now for positive charge, the electric field at P will be E of plus q, so q by 4 pi epsilon naught. This is r minus a whole square, because here it is, so from plus q to P, so here it is from O to P is r, but O to plus q is a, so it will be r minus a whole square. So r minus a whole square. Now hence the resultant electric field at point P will be, so E axial is equals to E of plus q plus E of minus q. And if we put the values of it, so we can take common q by 4 pi epsilon naught and 1 by r minus a whole square, then minus 1 by r plus a whole square, p hat. Now if we simplify it, it will be r minus a whole square and r plus a whole square. So we can take r minus a, r plus a whole square, and in the above it will be r plus a whole square minus of r minus a whole square. So in the numerator we can write this is a plus b whole square minus a minus b whole square, and we know that it is 4ab, that is it will be 4ar, and in the denominator it is a minus b into a plus b, so a square minus b square, so r square minus a square, and this is whole square, so this is whole square. So if we simplified it, it will be 4ar by r square minus a square whole square. So in the next step we can write 1 by 4 pi epsilon naught, and 4ar is simplified to, we know the dipole moment P is equals to q into 2a, so q into 2a, so 4ar if we separate it, so it will be 4ar, so we can write 2a, 2 into 2a into q here, so it is q into r, so it will be 2, and this term is p and this is r, so 2pr. So the total expression will be 1 by 4 pi epsilon naught 2pr by r square minus a square whole square and p hat. So here q into 2a is dipole moment. Now for r very greater than a square can be neglected compared to r square. So if we neglect this term, so it will be r square and whole square. So the expression will be 2pr by r square whole square. So it will be r to the power 4 and 2pr. Now if we cancel this, so it will be r cube. So 1 by 4 pi epsilon naught 2p by r cube p hat. So the expression will be this one. Now clearly electric field at any axial point of the dipole acts along the dipole axis from negative to positive charge, that is in the direction of dipole moment p vector. So this was the expression. So E axial is equals to 1 by 4 pi epsilon naught 2p by r cube p hat.